In the previous tutorials, we have built up our bank projects and we have seen writing unit tests for the contracts. And we have actually see how you can use examples that are expressed as test cases to make sure your pre and post conditions are neither too strong or too nor too weak. And we also try to demonstrate that when you actually get a red bar from the ES testing library report, then you should really use the breakpoints and debugger to reveal the place where the contract violation or the unexpected output occurred. In which case, you really have to make sure you use the breakpoints to pause the execution at the suspicious points, and then you can examine the values of objects, local variables, or arguments, or you can even use the watch expression facility in the debugger mode. And once you actually find out where the errors are, you can actually fix your code and then rerun all the tests and to make sure you do have a green bar. And only if you get a green bar can you actually proceed with further developments. So this is indeed a summary of test-driven developments, and that's a very important lesson to learn for this course. Okay, so for this tutorial, we are actually going to extend our bank projects with new classes and also new features to the existing class in order to further implement our business rule or the requirements. Okay, so let's, as usual, we're going to launch the terminal. And first of all, make sure we are in the right place for the workspace for the course. And we're going to launch the correct version of iFlow Studio that corresponds to the current term, summer 2015. And ampersand to launch the process in the background. Let's wait for iFlow Studio to appear. And we are going to double check on the project location and make sure it is okay. And then we are going to open this existing project for our bank projects. Let's open that. Okay, so for the purpose of this tutorial, we are actually going to implement some new requirements. As we said before, it's a very important practice for us to document in the class header. So now we are in the context of the account class. In its header, the first thing we ever did when we first created the class was to make sure we clearly states its responsibility. And also we list all the requirements that are supposed to be implemented. So these requirements are of the most concerns of your customer. So you really want to make sure somehow they are reflected in your final system. So what we have achieved so far is we express the constraint that account balances never exceed the credit limits by using a class invariance. And we have emphasized this for many times in the previous tutorials. And the invariance is supposed to constrain the value combinations of attributes to make sure the values that are actually allowed throughout the lifetime of the account objects is indeed respecting the requirements. Okay, and the second requirement we have only implemented part of that, which is the withdrawal feature. So today we are actually going to implement the deposit, and we are also going to implement R3 and R4. So the new notion we are going to introduce to this project is about the notion of time, because we want to be able to say whenever we do deposit and withdraw, by default, they are going to be done today. And for the tellers, the requirements ask us to implement the facility that the tellers can actually call some feature that can withdraw on a particular date and also to deposit on a particular dates. We're going to show you the withdrawal version in this tutorial, and the version for deposit will just be symmetric. That will be left as an exercise for you. And as for R5 and for R6, we'll do that in later tutorial, or you can try to tackle that as an exercise as well. Okay, so that's basically the overall goal for this tutorial. So first of all, because we are actually going to use the notion of time in this to extend this project. So let's first of all, let's add the necessary library into our project, which was not included in the previous developments. So the library we need is called time. So let's always go to projects and project settings when you have to configure your projects instead of editing the ECF file directly. So let's go under groups and go under libraries. So you can see so far we only have got base and eSpec, the testing library. So we want to add a new library. Again, either right click on the library and say add library, or click on that. You can see there's an icon here to say add new library. So either one will work. So let's add a library here. So let me type the name of the library, which is called time, and the time library here. Okay, as you can see here, by default, iPhone actually chooses the voice safe version of the library. So you want to make sure, since all the all the facility library that we are using, namely the base and eSpec and now the time, they are all voice safe. That will actually also give us a very high standard project, which means we are trying to check for voice safety at the compile time. We actually see one of the issues is indeed revealed by the voice safety type checker, as we'll see later, and how we can fix that. Okay, so we're going to import the voice safe version of the library, and let's say okay. You can see now time has been added, and also you can see the path here is relative to the environment variable that has been set when you first install the iPhone Studio. Let's say okay, and let's compile, and you can see that now in the groups explorer we have libraries, and under that we do have the time library here for us to use. Specifically, we're going to use the class that is called date. So this actually comes from the time library we added. Specifically, whenever we do deposit or withdraw, by default is going to occur today. So we actually have some feature there called make now. So this is going to be the feature that we're going to use for the purpose of this development. Okay, so now that we actually got the library included, so let's now create the notion of a transaction, because somehow we want to group each deposit or withdraw transactions value with their particular timestamp. So somehow we want to encapsulate the idea of value together with its timestamp into a transaction object. Okay, instead of saying we simply just reveal the detail about the value and the dates, we want to encapsulate them into an object. So remember, encapsulation is a very good practice in object-oriented programming or software construction. Okay, so we want to create a new class as to extend the business logic, and let's go into bank cluster. Click on that. We can right click and say new class, or you can see the icon here for adding a new class. Either way, so let's add a new class here, and then let's call that transaction. Okay, so now we don't actually need any specific parent class to inherit, so that's okay. So as always, so we have to put a meaningful header to documents. A transaction encapsulates a pair of deposit or withdraw value with its time stamp. So that should be quite reasonable to have. Okay, author, of course, you have to also give yourself credits. Now, okay, so now we are creating a transaction class. As I said before, we are actually trying to encapsulate things. So first of all, let's declare our attributes. So here we have basically two attributes, and we have value of type integer, because remember from before our withdrawal value has been integer, and the balance credits have been integer as well. So we just be compatible. So value is of type integer, and we have some attribute called dates. So this is like the timestamp associated with the corresponding deposit or withdrawal value. And this will be of type dates. This dates, remember, it comes from the time library we just added. Okay, let's put better organization here. Okay, so now because we actually have actually two attributes, and now we got to think about what kind of constraint we want to impose on the possible values on the attributes throughout the lifetime of the transaction objects. Let's say for now, let's just put a very simple invariance here. We can say valid value. Let's say always you have to either deposit or withdraw some positive number. So for example, you cannot deposit -5. You cannot deposit, you cannot withdraw -5 either. So you have to say something like, so value has to be greater than 0. Okay? That's our, okay? So now you can see what's going on here. Okay, we try to compile, and we actually have some compile time error. Remember in the previous tutorial, I mentioned that whenever you see an error message like that, variable is not properly set, attributes, dates. Okay, first of all, dates is actually of reference type. Of course, it's of type class date. Whenever you see such error message, it has to do with the void safety check. Because remember I said before, let me show you again. So if you go to project and project settings, if you look at our target bank project here, you can see the void safety option has been set to complete, which means the IFA compiler is going to compile, is going to check at the compile time to see if you might have any void targets violation at the runtime. Okay, so the IFA compiler or the type system is able to check it at the compile time to make sure it never occurs at the runtime. Okay, so what's happening here is we declare some attributes of some reference type which might be void, but we never actually initialize that. So that's the issue. Okay, so we actually want to have some constructor for initializing some transaction. Okay, so now we're going to have, let's say, a single constructor called make, and it is going to take, let's say, both value and dates. Imagine that if you're now in the context of the account class, if you're trying to withdraw, you will actually, for each withdrawal, you have to create the corresponding transaction with its withdrawal value and the now timestamp. So that's why we need to take two parameters for the make feature. Okay, so here we will actually put simply v to be the new value and d as the new dates. Okay, so now we can put comments here. Initialize a new, we can say simply say initialize a transaction with value v and dates d. Okay. Now, always do the contract first before you write the code. So what do we expect to achieve? Okay, we haven't done that yet, but let's do the contract first. What do we really expect to achieve after the initialization of a transaction? Certainly, we certainly expect something happened according to what v and d are. So we want the new value. So we can say value is set, and also the date is also set. So in this case, we would say value should be, our value, which is an attribute here, should be equal to the v, equal to the arguments. And also dates is equal to d. Okay? So this is, let's have already, we can have a look at the contract view. So if you look at the contract view here, you can see that, okay, we actually haven't declared that constructor yet. Let's do that first. Let's go to basic text view here, and we are actually going to declare make as a constructor. So to do that, we'll say create, make a create clause, and then make it there. Okay, so let's make sure it compiles first, and It wouldn't because we haven't initialized the date yet. Let's see if that will show in the contract view. It might be the case that it will only show after your code compile. So let's maybe do the initialization first. Okay. Okay, now we have to do the initialization. How do we satisfy this? It should be quite obvious. It can simply be achieved correctly by using two simple assignments. So value attribute is assigned to be the value of v, and dates is assigned to be d, right? Okay, so now it compiles. Let's have a look at the contract view. Okay, and so you can see now, here we actually have the transaction class with two attributes, date and value, and their values are constrained by this invariant here, which is simply that the value is greater than 0. Okay, it's always positive. And also we have the constructor here, and it has the post condition here, meaning that every time when you initialize a new transaction using v and d, then the new value and the new dates should be equal to v and d respectively. So that's what the post condition is asserting. Okay, so now that's it for the transaction. So the next step is, so now we already have a class that actually encapsulates the idea. Later on, when we each instantiation of a transaction class would be an encapsulation of the date and value for the particular withdrawal or deposit. Okay, that's already done. That's already done. So now what we have to do is to switch to the context of account. Okay, so here we are actually going to now first declare. We need two new attributes. We used to have just a balance and credits, but now because we might do deposit and withdraw at different time. It might be today, or it can be tomorrow, or it could be a week from now, or we are actually keeping a history of the, basically we are keeping a history of the deposit and withdrawal. So what we would do is to say deposit, standing for the list of deposits that we have done so far for the account. And also we have withdrawals, which is a history for the withdrawal, of course. So now we need to declare a type for both of them. So they are actually a collection type. So let me just put list, and then I will show you what list looks like. So it will be a list of transaction. As we discussed in the lecture, so basically if you go to the list class, so list class actually has a generic parameter as opposed to simply a list of objects or list of any. So in this case, whenever we actually instantiate the G over here by some valid class, it's going to replace every occurrence of the G in this collection class. As we mentioned in the lecture, so this is a very valuable way of checking your type correctness at the compile time. Okay, just refer to your lecture notes if you have any doubts. So now in the list class, you can see that the list class is actually deferred, which means you cannot directly instantiate the list. You actually have to find some effective class that effective descendant classes of the list. So this is the similar idea to the abstract class and non-abstract class in Java. So you can never directly instantiate an object from abstract class. You always have to find the non-abstract child classes of the abstract class in order for the instantiation. It's a similar idea. So how do we actually find out what are the possible descendant classes of list that we can actually use to instantiate the deposits and withdrawals? How do we do that? So let me show you. So if you just expand this panel here a little bit, so what we're going to do is called a pick and drop feature of IFO. First of all, we actually want to look at some class information. So you can see that in the if you click on the correct tab here, class, so you actually have different options here. The one we want to look at is we want to see what are the descendants of a particular class. And you can also see what are the ancestors of a particular class. and also what are the clients and what are the suppliers of a particular class. So this is a very useful information tool for you to know about a particular class. So somehow we want to choose list and drag and drop it here, okay, into this empty area here, so that these icons here will be applied to the list class specifically. The way to do it is to right-click on the list and right-click on the pick class list. Okay, again, two right clicks basically. Right-click on the list and right-click on the pick class list. As you can see, we actually have some blue ovals here, and then now right-click again to drop it here. Okay, three right clicks basically, no left clicks. Okay, now you can see that list is over here. So now we want to see the descendants of the list. As you can see, we actually got different descendants for the list, and one of them is actually called linked list, for which most of you should be familiar. So you can see linked list is actually a valid descendant class of list. So we are actually going to use the linked list class to instantiate the deposit and withdrawal history. Okay, that's about the tool, using the tool to find out what are the existing clients, supplier, ancestor class, and descendant classes of a particular class by using drag and pick and drop. That's the term in iPhone. Pick and drop by using three right clicks. Okay, if you are not really sure about this, please just rewind a bit to see what I did. Let's close this, and now let's try to, let me also can switch back to the output panel here, so that if I got any compile time error, I can see the error messages. Okay, so now we are declaring two attributes here. What I can do is I can put some comments here. So history of deposits, history of withdrawals. Okay, so let's try to compile and see what happened. If we will try to compile, again, this has to do with void safety. So it complains that the withdrawals and deposits might be void because you haven't initialized them in your constructors, right? Property not properly set. Okay, so now let's go to the constructor here, and we want to initialize the deposits and withdrawal. Remember we said before, you should have create, and then if you simply say, for example, deposit, and you try to do the code completion, it wouldn't complete because, as I said before, the static type or the declare type for deposit and withdrawal is actually a list, which is a deferred class. So you cannot directly instantiate the list class. You must pass some valid descendant class. That's why if you simply do the direct code completion, it wouldn't complete because somehow you actually have to say which descendant class I'm talking about. So as I said before, we'll do linked list. Okay, and here, and we want to do dot make. So the make feature actually comes from linked list, and it is going to initialize an empty list. Okay, and we'll do the same for the withdrawal. Okay, let me just copy the code and change this here to be withdrawal. Okay, and see what happened. Okay, so here we actually have some compile time error. Let's try to read the messages here. So type has wrong number of actual generic parameters. So this has to do with generic parameters. Okay, so now you can see that here we actually have some linked list as we wrote here, but it is expecting linked list of G, right? So if we go to, for example, the linked list class and see what happened. So the linked list class is actually a generic class because you can see there's a generic parameter G here for the member type. So that means every time if you want to instantiate a linked list, you must tell the compiler what the member type is, so that if you try to do any operation with the member, iPhone compiler will be able to figure out if the operation is valid or not based on what the instantiate G is. In this case, we actually want to instantiate the G to be transaction. Okay. Okay, now let's also do the same for that. Let's try to compile. So now it compiles. Okay, so now we want to write some contracts as well. Okay, so now we want to say after the initialization, the deposit should be empty, right? So now we can use some feature from the linked list, because deposit is actually of type linked list or the list. So deposit dot is empty. So basically we want to say the initial bank account should have an empty history of deposits, because we haven't done any operation to the brand new objects yet. Similarly, we also have an empty history of withdrawal. So here we would say withdrawals. Let me write it in a different way, but that's the equivalent. So we can say count means the number of elements in the current withdrawals list. That should be equal to 0. So it's empty is equivalent to .count equals 0. That should be quite obvious why they are equivalent. Okay, so now we compile and let's try to do, okay, we have done the post condition for that. We have initialized the two linked list. So now that means we have properly initialized the two history to be empty. So now, but how do we update the history, right? So now the way to update that is to look at what commands you have in your current class. So currently we only have the commands withdraw, and the withdraw should only extend the history of withdrawals. It's not going to do anything to the deposit history, right? So what we can do here, so what we have to do here is to make sure we update the withdrawal history properly. Okay, so by default, whenever we call the withdrawal without telling what date we are doing the withdrawal, by default, it is actually today. Okay, so what we're going to do is to declare some local variable. Okay, so you have to remember the order of putting the required local due, etc. So require is the precondition of the feature, so always it has to be satisfied. Only when it is satisfied will you actually go ahead and do the implementation execution. So given that, you should really declare local variable here for your implementation body to use. In this case, because we know for each withdrawal, we are actually going to extend the withdrawal history list with a new transaction. So let me declare that particular new transaction as T. And we are also going to say the today's date as D. Okay, so let me compile that. And now let's, first of all, so here we, as before, we are trying to update the balance. So we have done that correctly as I showed in the previous tutorial, and the precondition remains the same. And now, first of all, let's create the dot make now, as I mentioned before. So that means today. And then we're going to create a new transaction that encapsulates the value that we are trying to withdraw, which is A, and the dates of today, which is D, as we just created here. And then we're actually going to add this new transaction to the history list. So you are supposed to look at the interface of the list to know what features you can use. But I can tell you the one to use here is to say withdrawals dot extend. So this essentially extend the new transaction to the end of the list. So this is a transaction that we want to use. Okay, it compiles, and now we are going to write some contracts, some simple contracts, to say withdrawals extended. So somehow we can simply say, for example, the size of the withdrawal has been incremented by 1. So dot count, which means its size is equal to old size plus 1. Okay. So this contract is good for the purpose of this particular tutorial. However, you do have to realize that what it is saying here is simply that the size of the withdrawal history list is incremented by 1, but it doesn't really say how it has been how it has been extended. First of all, you got to make sure the new transaction is in the new list. And also, everything that used to be in the old list must still be in the new list. Okay, but this is something we are going to cover later in the lecture to make sure your contract is complete. So this contract here is incomplete, but we're going to live with that for this tutorial, just for the demo's purpose. Okay, let's compile and make sure, okay, it compiles. So now we are now done with the withdrawal. So what we have done so far was to say for the withdrawal, because we have introduced two attributes here, there's one thing I can do, which is I want to make sure the deposit is unchanged. So what I can do is to say deposits unchanged. And here I would say deposit size is equal to its old size without being incremented or decremented. Okay, so what we have done so far is, because we have declared two new attributes here to incorporate the notion of time. So that's why we have to make sure for all the updates, including the constructor, we have to handle these two attributes, or we want to make sure we update them to initialize them and update them properly. So that's why we have to extend the implementation and contracts of withdrawal to make sure the two new attributes are mentioned, are properly updated. Okay, so that's for the withdrawal. And now we're going to do a symmetric command, which is deposit, which means we're going to add new balance. We're going to increment the balance by the proposed amount. So let me just, because they're going to be symmetric, I'm going to copy the deposit and I'll do the modification in front of you to make sure you understand. Okay, so we're going to do deposit. So we're going to deposit an amount A into the current account. And in this case, we actually, for the withdrawal, you actually want to make sure your balance does not go too low. But since for the deposit, you're always going to increment your balance, so you never worry about it being too big, would you? So we only keep the precondition that you always try to deposit a positive amount into your account. Okay, so now, as before, we have the transaction to be added and the current dates. And now for the balance, instead of decrement, we want to increment the balance by the proposed amount. So now we create the current dates, and we create a new transaction that encapsulates the deposit amount and also its timestamp. And now, instead of changing the withdrawals list, we want to change the deposits list, right? Okay, now we don't need this anymore. That's actually specific to the withdrawal. Okay, so now balance set, we want to make sure the balance equal to O balance plus A. Credits remains unchanged. And also here, only the deposits history will be extended. So let me just copy that. So deposits.count equals O deposits.count plus 1. And on the other hand, withdrawals history will remain unchanged. Okay, so we're going to say withdrawals.count. Withdrawals.count is equal to old withdrawals.count, right? So this is our definition for the deposit. Okay. So now we have done we have extended the definition for withdrawal, and we have added a new feature for deposit. Now we're actually going to write a variance version for withdrawal, which is called withdraw on dates. So on a particular date for the teller will be able to say, I want to withdraw on a particular date. And that's exactly what that's exactly what R3 is requiring. So tellers can date a dollar deposit or withdrawal different than today. Okay, so now we want to withdraw on a particular date. So let me put that right beneath withdrawal. Okay, so we're going to have a feature called withdraw on dates. So let me do that. It would be also similar to the withdrawal. So let me also copy that, and I will do the necessary modification in front of you. So now withdraw. So now the arguments will be different. The parameters will be, instead of 1, that will be 2, which is, first of all, we got to make sure the name is right. So that we withdraw on dates. And it should be quite obvious. Other than the amount you want to withdraw, you also want to pass what's the dates you're trying to withdraw, right? So here, the precondition should be the same. So let me just remove the one that's too strong. You should be able to understand that from the previous tutorial, okay? That's not the focus of this current tutorial, okay? So now let's change the comments here. Withdraw an amount A from on dates D from the current account. It might read better if I put the dates here on date D. Okay, so now what we're going to do is we are going to withdraw from that particular dates for that amount. So first of all, we have to make sure that we have to also do the updates on the balance, and also we want to make sure we extend the withdrawal, right? Let me get rid of that. So before, for the withdrawal case, we actually have to create the current dates as today. However, because we already have the dates D as the parameter, so this part is not so necessary. So what we have to do, so what I meant was we don't need this D local variable anymore. What we need is, we don't need to create the D anymore. But here you can see now D, instead of referring to today, it refers to whatever dates that you pass as arguments. Okay, so we are making the new transaction here by encapsulating the proposed amount for withdrawal and the proposed withdrawal dates. And now we also extended withdrawals over here. So now the balance has been decremented, credits remains the same, and also the history of withdrawals has been incremented, and also deposit history remains unchanged. Let's try to compile. Okay, it compiles. And you can also define yourself, maybe deposit on dates. You'll be very similar. You can do that by yourself. Okay, so now what we will do next is to write. So you can see so far we have got how many, let's have a look at it under the feature explorer. So we have balance, we have 4 attributes: balance, credits, and also we have deposits history, and we have withdrawals history. And we have the constructor to initialize all of them. And we have 3 commands so far. We can withdraw, presumably on today, and we can withdraw on a particular dates, and we can also deposit also on today. So the next feature we want to write is not a command. We want to write some query, which means you can ask about the current, you can ask something about the current system to return some meaningful or useful results. So this kind of feature is called query as opposed to commands. Okay, so let me create a new feature bookmark. I would say queries. And now here so this new query that we want to put is to return all the withdrawal. So given the history of the withdrawal, if I tell you a particular dates, can you tell me all the withdrawals that's actually done on that particular dates? Okay, that's what this query is supposed to do. So we call that withdrawals on. Okay, it might be more grammatically correct if we say withdrawals on, because that's a noun. Okay, withdraws on, so dates, and we're going to return an array. So this will demonstrate the use of array of transaction. Okay, let's put the comments first to give the informal description. So this is going to return the list. Even though I say list, but we're going to return an array. That's okay. Return the list of withdrawals in the history that whose maybe it would be better to say return the maybe it would be shorter to say return a list of withdrawals done on date D. Okay, you can actually also make it better if you think you can think of a better way to write it. Okay, so now what we want to do is to return an array. Okay, so now let's write a contract first. Writing this contract will actually require something that you haven't been taught so far. It will be more sophisticated than simply say, balance equal to O balance plus one or things like that. You actually require some notion of quantifier, but we're actually going to cover this later in the lecture or possibly later in a later tutorial video. For the purpose of doing comments, we can just put the comments here. Okay, so basically we want to say for all the transactions that's in the list of withdrawal that's stored in the history. So this is kind of similar to the universal quantification notation that you learned from 1090. So it shouldn't be too new to you. So for all the transaction TR that's in the list of withdrawals, because withdrawals is simply a list of transactions, so this is type correct. It is the case that if the transaction, the dates field, remember in the transaction we do have the dates and value, right? So if the dates field of that transaction is actually equal to D, then if and only if, that which means implies on the both from the both sides that result, which is the list that we are trying to return, dot has tr. So this is to say, if in the history, if a particular withdrawal happened on day D, and so that and then that withdrawal should be included in the list, and vice versa. So this is just informal. We'll learn later to see how to translate this predicate notation, quantification notation into executable contracts. That will be the focus later. Okay, so now what we want to do is to, so here again we have the void safety problem because we declare the return type to be an array. So that means the result in this context refers to is actually of type of the return type because that's actually a reference type, so it might be void. So we must explicitly initialize that. So the way to do that is to say create result dot. So you have different constructors from the array. Again, code completion will be control space. We can simply make an empty array. Okay, so now I'm going to show you how to write a loop that can iterate through. First of all, the basic algorithm goes as follows. We are going to iterate through the list of withdrawals in the withdrawal history. So that means I'm going to show you how you can walk through a linked list for this particular feature. And then for each item that we are currently iterating through, if that item, which is a transaction, if that transaction states matches D, then we should include that transaction in the results. Okay, so we should also have some notion of expanding the initially empty array by all the transactions whose states actually matches the argument date. Okay, so now we're going to run a loop. So the way to run a loop is you type the from keyword and then type enter. It provides with you the skeleton of a loop. So this part here is the initialization of all the loop related variables. And this one here is the exit condition, which means when this condition is satisfied, then you will exit from the loop. So this is kind of the opposite way of writing the loop as in Java for loop. Because for loop, the middle condition, as long as it is true, then you will stay in the loop. But here, as soon as this exit condition is true in IFO, then you will actually have to exit from the loop. It's just different way of writing it. And here, this is the loop body, of course. So now we want to iterate through the withdrawal list. To actually walk through the list, again, you're supposed to look at the interface and lecture notes to see how you're supposed to use the interface. But basically, the pattern to follow would be, first, we are moving some cursor from the beginning to the end of the list. So now we are iterating through the withdrawal. So the way to say initialize a cursor is to say start. Okay, so we're going to iterate through the list until the cursor is now at the end of the list or goes beyond the list. So that condition, that Boolean condition is provided by the feature after. That means after the end of the list. And now, how do we actually say now walk one step further on the list? So the way to say that is to say withdrawals dot forth. So go forth. Okay, so these are the three basic operations for iterating through a list. Okay, so now we can declare some local variable here. So what's the current transaction that we are talking about, that we're iterating through? Let me just use a local variable to capture that. So here you can say that T is assigned to be withdrawals, because that's the list we are iterating through, dot item. So that means whatever the cursor is currently pointing at, we're going to return that item to T. And because remember, we actually instantiate the, let me show you, because we instantiate the list with transaction. So that means this item here is going to be of type transaction. Okay, that's really the benefits of using generic parameter. Okay, that's the transaction here. And what we're going to say, and we are also going to have a way to expand the array. The way to do that is we have to keep track of which position we're going to store into the array. Because our array in IFO, if you don't explicitly specify its lower bound and upper bound, you always start from 1 rather than 0. Okay, so now what we will do is to say we declare some counter for keeping track of what's the index to go into the array for the expansion. So we'll say I is an integer, okay, for the loop counter basically. And initially, I should be assigned to be 1, let's say. So you actually have two ways to write this. Either you say 1, or you can say because result is actually an array. So it actually has its lower bound available as a feature. So it's called lower. And for its upper bound, it's called upper. Okay, either way. But let me just follow, maybe just say 1. You can play with the lower and upper later yourself. Okay, let's say I is equal to 1. And then every time, of course, we have to also increment the I each time in each iteration. Okay, so now we're going to say something like, so I basically represents the spot in the array that we want to go into, okay, to do. So now the feature we're going to use in the array to put the new elements is called force. So this is particularly useful when you are trying to add new elements into the array, and the array will just be resized automatically. So you can actually look at how to use this force in the lecture notes and in the textbook. Okay, I'll just show you how to use it. Now, let's go back to account. So we are actually going to say if it is the case that withdraws dot, oh, actually we have that transaction already. If the current transaction being looked at in the iteration, and if its date field is somehow equal to D, okay, and then if that's the case, we're going to say this result array is going to be forced. with an elements. Okay. So now here we're going to force the transaction here, and then we're going to put the t to this position here. Okay. So let's try to compile. Okay. However, I need to tell you that this here is actually not going to work. Okay, so this I need to put a side notes on here for you to understand the rest of the tutorial. So I need to use this. Okay, the difference between equal sign and tilde is really the difference between reference equality and object equality. Let me pause here a little bit and go to my notes, and I will show you quickly what I really mean by those. Okay, so you really have to distinguish between reference equality and object equality. Let's look at the reference equality here, and assuming that we have two transactions, so T1 and T2, for example, or date 1 and date 2. It doesn't matter, as long as the two objects are of the same type. Okay, so whenever you're writing T1 equals T2, first of all, this is a Boolean expression because this is equality. Whenever you say T1 equals T2, what do you really mean? So basically, you are saying that, and I'm actually asserting that if T1 and T2 they are pointing to the same transaction objects, okay, or basically if T1 and T2 are the same address for the same objects, it's a very strict equality because they are only equal if they are really the same objects in the physical memory. Okay. Now, as for the object equality, it's actually more flexible. Okay, and you can write the object equality in one of the two ways. The one I just showed you for the dates example there is using tilde. It's more like a binary operator, or you can use a feature call which is called is equal, and the is equal feature here is like the equals method in Java. Remember, in Java you can always redefine your equals method in your own class, so that because of a dynamic binding, it will be called the right version at runtime. Excuse me. It's the same situation in IFO. So here, if we say T1 dot is equal T2, so here we are really saying are the two transactions considered as the equal transactions. So here equal, what should I should really put in double quotes, because what do you really mean by equal? So two transactions might be equal even if they do not refer to the same objects. So here comes the difference between reference equality and object equality. Okay, so now, like in Java, the equals method is inherited from the object class. In IFO, the is equal feature, which takes another object and also returns a Boolean. So that one actually inherits from any class. So any is like the objects in Java. Okay, so the is equal feature in the any class simply just does the default behavior for comparison, which is which is to compare by object references. Okay, so that means when you are doing T1 tilde T2, it depends on if you have redefined the is equal feature in the transaction class or not. If you have not redefine the is equal feature in the transaction class, then writing T1 and tilde T2 is essentially the same as writing T1 equals T2. That means, in this case, if the is equal feature is not redefined, then object equality and reference equality, they are equivalent notation. They are the equivalent notion. Nonetheless, usually you will actually want to redefine their own equality for your business objects. You want to say, for example, for transactions to be equal, I don't really require their addresses to be equal. As long as their dates and values are equal, then they're considered as equal. So if the is equal feature in the transaction class for the two objects is actually redefined, then T1 tilde T2 or T1 is equal to T2. It depends on how the is equal feature is redefined. Okay, I hope this quick overview, which I believe you already know from your previous Java class, I just want to refresh your mind just in the context of IFO. Okay, so this is why we actually have used the tilde here, because for dates, we don't really care if 2 days, let's say both October 15. So maybe this particular object, date object of October 15 is stored somewhere, and another October 15 object is stored elsewhere in the memory locations. But when we compare them, we only care if they actually have the same month and day, right? So we don't care if they are actually stored in the same physical location. So that is why we're using the tilde notation here. Okay. So let me recap for this particular feature here. So for this particular feature, we are trying to return the list of withdrawals that are actually done on a particular date D, which is passed as arguments, and we're going to return an array. So the way the algorithm works is by iterating through the withdrawals history, which is a list, and the way to traverse through a linked list is by manipulating a cursor, and start feature initializes the cursor. After is actually a Boolean query to tell us if the cursor has go beyond the last position in the list. And fourth, we actually just move the cursor from left to right for one position. And so these are the three critical features for you to iterate through any list, like a linked list. And from until loop end is actually the syntax for for loops. And until here is different from the middle condition for your for loop in Java. Until here is the exit condition, which means as soon as we reach the end of the list, then we should exit from the loop. Otherwise, we might just end up in some infinite loop, which is not good. Okay, so this is loop body here, and we also have some loop counter here to say where in the array we are trying to expand the empty array. For example, initially the array is simply empty. So I is initially 1. So let's say the first time we're going to see if the first withdrawal in the withdrawals list is actually if its state is actually matches the D, then we'll certainly expand the first position in the array by this particular transaction, and so on. Okay, so that's implementation for the withdrawals on query. And here we actually have the informal, although it means the formal universal quantification, but since you haven't learned how to write this as executable contracts in IFO yet, so I just put that as a comment for you. Okay, so now we need another feature here, a query here, which is called withdrawals today. So basically, you can basically tell, you can very easily tell what the feature is supposed to do. Basically, we want to return the amount of withdrawals done today. So like how many dollars you have withdrawn so far, because you might have some maximum limits, right? So now here, what we will do is instead of returning an integer, we're going to return an array. So this withdrawals today can actually make use of the withdrawals on. So let me show you how. Okay, so now the way to do this is, so first of all, because now we don't actually have any parameter here as a date, so we are going to create today the dates. So local, so we'll see today, and that should be a date, and we'll say create today dot make now. Okay, so that is the object for today, and what we're going to do is we're actually going to reuse the query that we wrote, because here D can be any date, and of course today is one of the possibility. So let me also declare some local variables. So today withdrawals, okay? So that should be an array of transaction, and this corresponds to the return type of this auxiliary feature here, okay? So there should be no surprise. So now let me just compile. Okay, compile is fine. Let's go on. So now we want to actually get the list of withdrawals of today by using the withdrawals on feature because we have already defined that. So we can reuse that. So now today withdrawals is assigned to be the withdrawals on. So now we want to, sorry, that's the wrong one to call. Let me do it again. Sometimes code completion may not just work so smoothly, so you gotta play with the tool. Withdrawals on here. So we gotta pass today here, right? So here we don't actually have to write the loop ourselves to iterate through the withdrawals history again, since we already have that, so we can just reuse the code, okay? That's also a very good practice. You want to repeat the code as little as possible and to reuse the code as much as possible. Okay, so now we're actually going to actually calculate to see what's the total amount from this return array. So that will correspond to the total amount of withdrawal values of today. So what you have to do is to say, so result, which is the integer here, initially, although this line may be redundant, but we can just explicitly say that. Starting from 0, counting starting from 0, again, we're going to run a loop. The way to run a loop for the array is we actually have to have a loop counter. So I is integer, okay? So now we have to initialize the loop counter. So I is, either you can say 1 if you are pretty sure that the lower bound of the array is actually 1. However, sometimes in iFill, they allow you to actually explicitly modify the lower index and upper index for the array. So the safest way to do that would be to say today withdrawals dot lower, whatever lower index it is for that particular array. And we're going to iterate through the array until the loop counter is greater than the upper index of the array. And in each loop iteration, we're going to increment the loop counter by 1. Okay, so let's also define a, because we're going to retrieve the transaction and also to see what their value is. So let's declare some local variable. So for each iteration, we are going to retrieve the transaction from the resulting list from the withdrawals on, right? So now we're going to say T will be equal to today withdrawals and what we want to index into. So this is indexing notation, which is to the left and right square brackets in iFill, like in C basically, or in Java. So now the current value for the loop counter should help us index into the current transaction. And now we want to say we want to accumulate results by adding t.value, right? Okay, this compiles and the looping and also the ensure clause post condition, we just ignore that. But that doesn't mean for your projects you don't have to write a post condition. I'm only saying for the purpose of this tutorial, to save time, we will show you actually how to write the contracts properly, maybe in the lecture, or you can come to me offline to see how to do that. Okay, so that's our feature. So let's recap a little bit what we have achieved so far before we go ahead and do the test cases. So because we have added the deposits and withdrawal feature attributes, so we have updated our withdrawal feature to make sure it updates the withdrawals history properly. And we have defined deposit feature command. We have also introduced the withdraw on a particular dates command. We also defined 2 new queries, which means they return something, but they do not modify the states. So we have withdrawals on, and also we have withdrawals today. If you really want a contract, what you can say is, you can say, for example, stay unchanged. And then you can say balance equal to old balance and credits is equal to old credits to make sure that this is indeed a query, which means the you can also put to say withdrawals.count equals old withdrawals.count, but I wouldn't write it here. Okay, and you can do yeah, that's what we can do. You can also do the same for this query here. Okay, but I just want to illustrate that to you. That's how you do the contracts. Okay, so now we are done with the extension to the account class. So now we're actually going to write a test case for the new features we have added so far. Okay, that's basically test-driven development. So you cannot just keep developing your software. You really have to make sure the new small extension you have introduced to your software is testable and make sure they are tested as correct before you can go on. Let me close that. So let me go to the test account class. So let's go to the end. So what we want to do is to do a so-called specification test, which means we remember before we were only testing about, let's say, only just a creation alone or just withdraw alone, just about one feature. But now this test case, which we call either specification test or integration test, it is actually to combine several features together in a single test and see how they interact with each other. Okay, so now I'm going to type it. So the one we want to do is called test transaction value and dates. Okay, the name should be quite self-explanatory, so I don't have to explain that. And we want to do a Boolean query, so we want to add a Boolean test case later. Okay, so let me just declare a local variable I need some account 8, of course. That will be the business objects for us to manipulate. And we also need some dates to test. So I'll just have today and tomorrow. And I also have some transactions. I'll just say W1, W2, and W3. And they will be of type transaction. And also I have the withdrawal that's done today. Okay, that's something I will test as well. Okay, I would say that's an array of transactions just to be compatible with the query type that I introduced. Okay, so now these are the local variables. So now let's just start making the dates first. So the way to make, again, code completion, you gotta be careful. So create today dot make now. Okay, so this is how we create today. Okay, so now let me make some comments for you. Create today. And now the next lines, we're going to say create tomorrow. Okay, first of all, the way to create tomorrow is let's create a tomorrow just the same as today. And then we're going to say tomorrow basically is one day after tomorrow, after today. So we actually have a feature called day 4th. Okay, so initialize tomorrow as today and then go that one day further. Okay, that's how you do it. Now initialize, and so even for the test cases, you better have inline comments to really tell either your clients or to remind yourself later what you're trying to test. So now initialize an account of 0 credits. So we would say create a dot make. So 0 credits here. And now we'll do some deposit and we'll do some withdrawal. So a dot deposit, let's say we do 1500. And here we'll say a dot withdraw on dates. So now we try to withdraw, let's say how much? 400 from tomorrow. So this will be actually like a teller operation. Okay, so 400 from tomorrow on tomorrow, and then we'll say a dot withdraw. So we'll do some today. So a dot withdraw 1000 and a dot withdraw let's say 4,000. Okay, so we have done one deposit, one withdrawal on tomorrow, and 2 withdrawals on today. Okay, let me just double check the amount: 1,500, 1,000, 4,000, and 400. Okay, good. So now we're going to do some mini test. So we would say results equal to a dot balance is equal to 100. So you should be able to figure out why this is the case, right? So after, yeah, so 1500, basically 1500 minus 400, 15100, and that would be, yep, yes, and then 14100, and then 4100 minus 4000 would be 100. Yeah, you can do the math. And a dot withdraws today. So this is like a query. Okay. So the amounts that we withdraw only today. Remember, these two are the withdrawals of today. So that should be 1000 plus 4000, which would be 5000. On the other hand, 400 shouldn't be included here because that's done tomorrow. Okay, and then we can say check result and let's compile. And there might be some typo here. Yep, indeed. This typo should be create. Okay, good. So now we are done with, this something very important I forgot. You should always put the comments for the test case. So you will have some meaningful explanation on the generated report. Okay, so now we're continuing from T4, so you'll be T5. Test transaction value and dates. And here for the comments, you can do the same. Okay, test. Basically, you can say deposits and withdraw transactions on dates. Okay, that should be reasonable. Okay, always remember to do good documentation. It's really crucial. Okay, so now what we want to do is to say to add this Boolean test case. Okay, and we add more mini test cases later. Specification test. So we would say add Boolean case, and we would say agents, and then we'll have that test and do the code completion here. Okay, now let's compile. We did compile, and now let's run the workbench system. Okay, because we are still adding to the ES test, and this is already covered in the application class over here. So there's no need to add a new add test unless we're adding a new test class, but it is not the case here. Okay, so now let's go back to test application here. Let me just go back. Test account here. So now let's run the workbench system to see if the test case is passed. Okay, it seems like we failed and we have some precondition violation. That looks suspicious. So let's see what happened. So you should really, up to now, I have shown a few times how you're supposed to see which precondition in particular that is failing. And once you have seen that, you should be able to set the proper breakpoint in order to do the debugging. Okay, let's see. Let me show you again. Apparently, this test failed, and at some point, we violate the precondition of the feature. Okay, let's see where. So let's just do the normal execution here. If we click on that, and let's see. Oh, by the way, so this is actually not the current feature we're looking at. It's actually a feature that is actually a test query that appears before that, right? And that's actually from the previous tutorial, so don't get confused. So we should go run again to see where we are. Okay, so now this is actually the precondition that's being violated. As you can see, the precondition belongs to the force feature. Remember where we actually use the force is actually in the withdraws on query in the account class. That's the only place where we use the force, the array.force, right? Let's have a look. You can actually also see that from the stack. So let's go from here. So this is the test case we are trying to test. That's the test transaction value and dates test routine we wrote. And from there, you can see up to now we were okay. So it is actually here. It seems like when we were calling withdrawals today, we actually got that contract violation. But up to here, even after the second withdrawal, we had no contract violation. That's why the yellow arrow paused here. Okay, because you can see A balance is equal to 100, cannot have any precondition violation for the array. So it must be this guy here that caused the trouble. Okay, so now with indeed, you can see the next one in the core stack, we have withdrawals today. And it seems like because withdrawals today actually make a helper call on the withdrawals on, right? Withdrawals on, actually over there, we actually somehow we're trying to do some force. It is this part that's the force causing the trouble. Okay, so let's see what the we'll come back to this context in a moment, but let's just see where it actually failed. So if you go to the force feature here in the array, you will actually see that the one that we failed was has default if too high. So somehow, if the position that you're trying to force into the array is greater than upper plus 1, then you will get that you should really have the default value for the elements type. Okay, it's a little bit advanced topic, but basically it is saying, let me show you some illustration on my desktop. So imagine that this is your array, and now we are trying to, let's say this array is simply empty to begin with. So you have nothing in the array, although I draw some elements there, but let's say there's no elements there. Okay, now if we got some initially empty array, and we are trying to, and assuming that the array starts from the index 1, 2, and 3, etc. If we are trying to force into position 2 with transaction T from into the empty array, that means we are trying to force into this position here. However, this position here, because we are talking about an empty array, so this position here is still uninitialized. And this is actually where the problem is. Imagine that if there is no void safety, if you simply just trying to directly force into position 2 in an empty array, that means position 1 will simply contain void, right? That means later on, any client who is going to use this array, if they were trying to access into this position here, they are actually going to get a void targets. They're going to get a void objects. And if they're trying to call any feature on this position here, they're going to get a void target call contract violation. Okay, again, if this is an empty array starting from the index 1, and if you're trying to force into the position that is actually not, so currently the upper is simply just 1. Okay, upper is 1, which means the next place where you can force into the array without any void targets. So now you're trying to force into position 2 without initializing 1. So that's where the trouble is. So that means if you might simply just have void targets here if you go here without initializing here. Okay, I hope this simple illustration is clear. So let's see. So that's what this precondition is complaining. But let's see how we actually end up with this situation from the withdrawals on. Okay, you can see that currently, let's see what's the size of the array. So remember, because we are returning an array, so the result is actually of type array. So let's see results dot count. So you can see now currently the result array is actually empty. But so what's the result the upper? What's its upper index? Okay, it's actually 0. And what's the value of I is 2. So it's exactly the situation I was trying to illustrate. So currently the array is actually empty, and you're trying to force this T here into position 2. But this array actually will start with position 1. But what's going to happen is if you directly force into position 2, let me open up that note again. If you're trying to force into position 2 without initializing the place of the objects in position 1. That means position 1 is going to contain void objects, which is not good for any other client who is going to access into the array, particularly this index. So that's what the void safety check can do for you. So it's telling you that no, you shouldn't use force in this way, and this is actually what they are doing for you. Okay, so this is actually the problem, and indeed this is not really what we want. Somehow we have not incremented the loop counter properly. Okay, so what we're supposed to do, I can tell you what the solution is, but you're supposed to figure out why such a fix can actually help. So what I have shown you so far is I have helped you trace back to where the contract violation occurred and how it has occurred. So we boil down into this improper use of the force feature, and we are trying to force into some location without initializing the locations before. So that means we might have the possibility of void targets. So that's why we actually fell in the precondition for the force. Okay, the way to fix that, let me go to where we were. Okay, so we were in this withdrawals on. Okay, so we are not supposed to increment I for every case of the transaction. We should only increment the value of I when we actually matches the proposed dates and also the date for the current transaction being looked at. Okay, so what we are supposed to do is to put these increments here. So that means we are not going to increment for each iteration. We're only going to increment the I when the transaction date is matched. Okay, you should really figure out yourself why this is the case. Okay, I'm just going to show you the fix, and I'm going to rerun the tests to see if that might help. Okay, good. So we have now fixed the problem here. So So if you're unsure about this, please rewind and pay attention to what I said and try to reflect to really convince yourself. Okay, so this mini test case actually passed. So let me do another one. We got 3 in total. So let's do the second one. So now I want to say today withdrawals. Remember, today withdrawal was actually a local variable here. Okay, so now we're going to say that one is assigned to be a dot withdrawals on. Okay, let me clear that. Withdrawals on here today, and now I simply want to make sure the result is equal to that today withdraw, which is an array, dot count equals 2. The reason for this is you can see that we have done 3 withdrawals in total, and the later 2 were actually done today by default. And the first one would not be considered as today's withdrawal because it was specified as tomorrow, right? So now let's do this mini test case and make sure there are only 2 withdrawals that are included in the history of today. Recompile and rerun it. Okay, this mini test case also passed. That's good. Let's do the last mini case. And this test case will, okay, let's see. Basically, what we are trying to assert is, because you can see that we have done basically 3 withdrawal transactions here. So each one of them will be encapsulated in a transaction and that we put into the history of withdrawals. So what we want to make sure is this today withdrawal should contain only 2 transactions, and those 2 transactions should correspond to the one that are created by this withdrawal and this withdrawal, but not this one. Okay, so what we're going to do is we're going to create the transactions for us to do the comparison. So let's say create w1.make. So this will be the transaction that corresponds to the let's say this one here, the first transaction here for the today's withdrawal, right? So here today, let me save some typing here. 1,000 And also we have 4,000. 4,000 is actually for the second withdrawal of today. And also we have the 400 for tomorrow. Okay, let's compile. And okay, so now what we want to make sure is, now, because today withdrawals is actually a local variable that captures the return value for withdrawals on today query call. So that one should contain only W1 and W2, but not W3. So we want to say today withdrawals dot has to make sure they are in the array, right? The has W1. Okay, let me organize them better. Okay, and do some code copy. So of course they are combined with conjunction because every one of them should be true. Okay, W1, W2, and in the case of W3, which will only occur tomorrow, then that one should not be in the array, right? And you would think this mini test case should also pass, but let's see. If it passes, that will be good. If it doesn't pass, then we get a red bar and we have to debug and fix. Let's do this. Too bad. Since because we know up to the second mini test, we actually passed. So it seems like it's the last one that actually didn't pass, right? So let's have a look. So let's have to double check again to make sure it's really the right check assertion that failed. Again, don't get confused. This is actually the previous Boolean test case that's from the last tutorial. So we just have to go on to the one we are looking at. Okay, so now we are in the context of the test case we are looking at for this tutorial. And somehow you can see that from the objects panel here, the result is actually false. Okay, let me use the expressions watch to help you. So basically we have a conjunction. So let me copy and paste. Okay, the first conjunct was actually false. What about second one? The second one is also false. What about the third one? The third one is true. However, somehow it would turn out it's actually true for not for the very good reason. So let me just delete this one for now. I think once we fix the first two, the whole thing will pass. Okay, so let me see. So why did it fail? That's something we want to know. So somehow IFO runtime says that W1 does not exist in this array, but to our understanding, they should have been added already by the withdrawal feature, unless there's some bug in the withdrawal feature. So let's have a look. What's W1? Sorry, typo. W1 is actually the withdrawal that's done on today with $1,000, right? And let's see, what's today's withdrawal? Okay, that's actually the return value from there. So let's have a look at what it is. Okay, let me expand this a little bit so it's easier to see. So now today withdrawal. Okay, it does have, you see the count of that is actually 2. And it has a lower index 1 and upper index 2, which means it currently has 2 transactions. That's why the previous mini test case passed. The first transaction there is, you can see that, you see 2015, May 24th, 2015, May 24th, the same dates. Now $1,000 and $1,000. So it seems like W1 is indeed in the today withdrawals, but somehow IFO runtime system tells us that it is not there. That looks very, very strange, is it not? Okay, so now what we have to do is to actually set a breakpoint over here, and then when we run the debugger, it's going to pause here, and then we'll step into the detail of has and see what happened. Okay, that's what we have to do. Stop the execution, and then we are actually going to run it again because we already set a breakpoint. This one is okay. We just want to go to our breakpoint. Okay, that's here. So now again, we're actually in the test account, and we are in this test transaction value and dates feature. That's the right one, and we are right before the checking of the membership of the W1 in today withdrawals. I believe the checking of W2 in today withdrawal will be similar. So if we can find an issue for this one, the fix should be the same for that one. Okay. So now instead of going step by step, if you go step by step, we actually skip all the details in the step and then go directly to here. So what we want to do is to say step into a routine. If we step into there, so now we are in the context of array, right? So if I just go to the call stack and see, so now we used to be here, now we step into the has feature of array because today withdrawals is of an array type. So let's go to has, and now let's go step by step to see. So now we are checking to see it, so you can see now we are in the context of array, and the arguments we have is the first withdrawal, May 24th, 2015, and $1,000 of withdrawal. So now let's go step by step. Step by step. So here's something we have to worry about here. So you see, so the has feature in the array distinguish between whether it should be an object comparison or it should be a non-object comparison, which means it's a reference comparison. As you can see, if it is the case of the object comparison, it's going to use the tilde operator. If that's for reference comparison, it's going to use the reference equality operator. Let me remind you a bit. Please do review the notes again for yourself. So reference equality will be the equal sign. Object equality would be the tilde, and the reference equality is very strong, saying that the two addresses should be the same. Okay, for object equality, if you have not redefined their is equal feature, then its meaning is the same as reference equality. However, if you want to make sure, even though two objects point to different locations in the memory, if they should be considered equal, if their certain fields actually match, then you should really redefine the is equal feature in the corresponding class. Okay, keep this in mind. So now, let's go back to iPhone Studio. So in this case, do we actually need reference equality or object equality? Let me show you what you need. If you go back to the test case here, so you see here, when we, for example, let's say when we do the first withdrawal, it will actually it will call the withdrawal feature. Let me show you how to see the definition for the withdrawal feature. So make this a little bit smaller. Also, you want to make this feature a little bit smaller too, so we can see the code. Maybe this is something I haven't shown you so far in the previous tutorial, but it's a very handy thing to have. So now we got three panels here. So this is the basic text view. This is the breakpoint view, and this is the object view. Don't get confused. You have to practice with this. Okay, now we go to the account class, and if we go to the withdrawal feature, you can see that in the withdrawal feature, given a particular value for withdrawal, let's say 1,000 here, so we will actually create a transaction, a brand new transaction accordingly, right? You see, this is a creation instruction. On the other hand, you can see, so here you can see some transaction with today and 1,000 has been created. And here, W1 is another transaction, although it has the same value and has the same date, but it's a brand new object of transaction. So if you're trying to do reference equality between W1 and the new objects that you create in the context of the withdrawal feature here, the reference equality will fail because indeed they refer to different transaction objects, although they have the same value and the same dates. So what you want to do is to make sure you redefine the is equal feature for your transaction class to make sure to make sure when the IFO runtime executes the equality, so two transactions are considered equal if their dates and value are equal, as long as their dates and value are equal. Even if they don't refer to the same objects. That's my point. Okay, you understand this point. Let me make another point. Let me go to the has feature again. So now you can see that that's really, so we really want to go to this branch here, provided that we actually redefine the is equal feature for, so here the item is indeed the item in the array, which is transaction. So now let's first make sure we can really go into this branch, so we can make sure when we redefine the is equal feature, which we haven't, but we will. If we can go into this branch, and once we actually redefine the is equal feature for transaction, and everything should work. But let's see if that's really the case that we can go into this branch. Let's go one step at a time. Somehow, you see the problem, this is the second problem. We know that we have to redefine the is equal feature so that tilde really means object equality with your own definition. However, somehow the array, so object comparison is actually some attributes of array. So let's have a look. So if you go to the array class, and if you go to object comparison, you can see that object comparison is actually an attribute in the array class, basically in the container. So array is one of the possible containers. So basically this is like a flag for the container objects to say, for this particular container, are you actually going to compare the member whenever you query for membership? Do you want to compare the member by reference, or you want to compare their member by equality? I mean by customized equality. Okay, so you can read this definition yourself. That's exactly what I said. And the way to change this flag, so this flag, because it's actually a Boolean, so by default, object comparison would be false. To turn this flag on, let me show you. There's something you have to call, which is called compare objects. Okay, so let me go back. So to fix the second problem, which is to make sure when we query about the membership in the array class, in order to actually go to this branch for the object comparison, we actually have to call the compare objects, right? But where to call that, I'll show you. Because now we are actually talking about this array over here, today withdraws. But where does that array come from? So this array is actually assigned to be the return value for the withdraws on. So that it seems like, so it is the case that the withdraws on array, that's the array that's returned by this feature here should have a compare objects feature call to make sure whatever that's returned is going to compare object equality by default rather than reference by default. Okay, so let me recap what the two problems are. So if I go to here again, first problem is, because we want to make sure two transactions, even though they are stored in different memory locations, they should be considered as equal as long as their dates and value actually match. That's the first problem. So we have to redefine the is equal feature in transaction class, which we haven't. Second problem is, we want to make sure when we at the runtime, when we call this has feature on the today withdraws array, which is returned by the withdraws on feature. Okay, that means that's the feature where we should change the flag of the return value array. Okay, so we want to make sure that we can actually go into here, and also when we call this, we want to go into this branch. To achieve that, we have to compare objects for the array. And to make sure this tilde here will actually call the correct version of the is equal, we have to redefine that. So there are two fixes to do. Okay, if you are still unsure about the two problems, please rewind and watch them again. I think I should have been quite clear already. Okay, so two things to fix. First of all, let's go back to our account class. And as I said before, it was the withdraws on feature, and because now we are returning an array, and because we haven't called any compare object, so by default the object comparison flag is actually false. So we'll say results dot compare objects, right? So we're going to override the default. So we can do some check assertion here to make sure it's really overwritten the default option. So results dot object comparison is a Boolean. Okay, so okay. Yep, maybe there was just a typo before. Okay, good. So now we are actually let me put some comments for you to make sure when, for example, calling result.has some t. T is a transaction, of course, is considered as contained in the array if and only if t is the date and value of t match any of the store transactions in results, right? So we are really doing object equality rather than reference equality. Okay, so now one more thing to do is we need to go to transaction and to redefine the is equal feature to make sure how we are defining the equality for transaction correctly. The way to do that is to redefine the version of is equal from the any class. So we would say, first of all, we have to say, because we actually want to say which version we are trying to overwrite. So we say inherits from any, and then redefine the is equal feature here. Okay. And if we compile, it's going to say, yeah, you say you're going to redefine that, but you haven't done that. Yes. So we are going to do that, right? So let me create a new feature bookmark. Feature, so that would be equality. So is equal other. Okay. So here, this is something that's also unique in IFO. So basically, this is called, so when we say like current, it is as if we actually say transaction. Okay, because transaction is actually the type of the current class of the current objects at runtime. So IFO has a construct called anchor type. That is to say, you don't actually have to do this. Here you can just say like current. This is actually useful, as we will see later in the course. This is actually especially useful in the context of inheritance, because in the child class, you actually don't have to actually say, when I'm comparing this transaction with another object, that object must be of type transaction rather than the any type. Okay, but this is not so critical for this tutorial purpose, but just want to let you know this is called anchor type, and this is as if we typed transaction here. Okay, so now are two transactions dates and value equal. Okay, so here we're going to say result, which is Boolean. We have to say Boolean here because that one is actually query, is equal to. So two things. So we're going to say value, which is an integer, equals to other dot value, and also date. Here, we actually better say object comparison as well, because for the dates, we don't actually worry about where the dates are stored as long as they have the same month and day and year. Other.dates here. So defining object quality sometimes a little bit tricky. So this example illustrates to you how you should deal with them. So I hope that's clear. Okay, so we have done two things. So we have make sure the container of the withdrawals on today actually compare objects by default. And because we know each of the objects stored in the withdrawals is transaction, so we also have to redefine the is equal feature of transaction. And the way to do the redefinition is by writing this clause here to say we inherit from any clause and we are trying to redefine the is equal version from there. Okay, let's compile and rerun the tests. Okay, good. So now we actually have passed all the test cases, and T5 is actually the new test we have introduced in this tutorial, which is to test the features that we actually have introduced in the account class. If you go back to the account class, you can see that in this tutorial we have developed quite a few features actually. So we declare two new attributes, deposits and withdraw, given that we have a new class called transaction, and we also extend the definition for withdraw so we can update its history and also withdraw on a particular dates, and we also define the deposit. So there will be a symmetric version for deposit on dates. You can develop that yourself. And so far we have tried to satisfy the R3 and also R4. So now we can do deposit and withdraw and or to access the withdrawal on a given date. That's exactly what we have done. So up to now, we have covered R1 up to R4 for the requirements in our software, and we have written so far 6 test cases, and all of them actually passed. So that means we get a green bar, and this will give us the mandates to actually go further with our developments. And that's indeed the essence of test-driven developments. Okay, so again, let me mention again, so it's very important for you to know why the issue with the force actually occurred. So please do think about that carefully yourself. And we also talk about the notes for the equality between reference and object. Please review the notes again. And that's what we are supposed to achieve for this tutorial. And in the next tutorial, we are going to show you that about the principle called it's called the uniform access principle. Okay, we are going to see that in a short video following this. So stay watching.